Hello everyone, we are coming to the last part of stability, and over here we're going to explore how lowering the center of gravity and having a wider base area leads to greater stability. We're going to use a box as an example for discussion here. That's because the box is regular shape, very symmetrical, and easier to understand. And notice that in this video, what I have is the red line indicate in the video as the base of the box. And this is the pivot. And I'm going to tilt the box about the pivot as shown. And notice the white line. The white line represents the line of action of the weight. Now note that this is an empty box. And so the center of gravity is right in the center. Right, suppose if we right in the center of the box, a three-dimensional box, but we are going to hang the string outside to represent the line of action of the weight. Now notice that when I tilt the box and the line of action of the weight falls along the base area, when I release the box, it returns to its original position. But when I tilt the box again about its pivot, and this time around the line of action of the weight falls outside the base area, the box topples over. So what I'm going to do next is I'm going to put additional weight into the box. And again, the red line indicated in the video is taken as the base of the box, and this is the pivot. And the box is going to be tilted by the pivot as shown. So based on the video, when the box is released, the box turns anti-clockwise about the pivot and returns to its original position. Now, note that there's additional weight in the box. In fact, there's additional weight in the base of the box. And now, I'm going to tilt the box at an angle larger than what I did initially. And note that the white string represents the line of action of the weight when the box is empty. So this is not the line of action of the weight of the new combination, alright? But you can use this line as a reference. Now, based on the video, when the box is released, the box turns anti-clockwise about the pivot and returns back to its original position, despite having a larger angle of tilt compared to when the box is empty. And the box yet returns to its original position. This shows that this additional weight caused the center of gravity to be lower, nearer to the base of the box. And so even though when you tilt it at a larger angle, the line of action of the weight still falls beneath the base area. And that's why the box is now more stable. Now how about I switch the box with a larger base area? Now the box will be tilted clockwise about the pivot. And so this is the position of the pivot, right? And this is the base. I'm going to tilt it clockwise. Now when the base is wider, you can see that the box can be tilted at a larger angle as compared to the smaller base before toppling over. Hence, the box with a larger base is actually more stable. In other words, I can actually turn a box with a larger base with a larger angle of tilt and release it, and it returns back to its original position. To summarize, factors that affect stability, base area, and the position of the center of gravity.